In order to find the critical points for a function, you first need to take the derivative. So let's go ahead and do that. F prime of x here is going to require use of the product rule because we have x times 2 minus x to the 1/3. I'm going to take the derivative of x, which is just 1, leaving the 2 minus x to the 1/3 alone. And then I'm going to say plus, now let's leave the x alone, and take the derivative of 2 minus x to the 1/3. That 1/3 will come down in front, 2 minus x now to the power of negative 2/3. And we must not forget the chain rule. The derivative of this inside function here is negative 1, so a negative 1 will pop out here. I would love to set this equal to 0 and solve to find my critical points, but there's too much of a jumbled mess here. So what I'm going to do first is rewrite this expression on the right. I'm going to say 2 minus x to the 1/3, he's fine, but I am going to rewrite this as minus 1 over 3 times 2 minus x to the positive 2/3. Also, there's actually an x in the numerator there, and so this is how this right-hand side gets rewritten. We're getting a bit closer, but we still need to work on this and getting a common denominator here. I'll point out that the denominator of this first term is simply 1, and so he needs to pick up a 3 and a 2 minus x to the 2/3 to share the same denominator. So let's go ahead and do that. I'm going to do this in blue. I'm going to say we're going to multiply the top and the bottom by 3 times 2 minus x to the 2/3 and 3 times 2 minus x to the 2/3. Now when I do that, my numerator up here becomes 3 times this times this. This 2 minus x to the 2/3 and this 2 minus x to the 1/3 will become 2 minus x to the 3/3, which is just 2 minus x to the power of 1. And I'll still have the 3 here, minus x from this guy, all divided by 3 times 2 minus x to the 2/3. Okay, now we're getting somewhere. I'm going to distribute the 3 and then subtract the x to get an answer, or a numerator of 3 times 2 is 6. 3 times negative x is negative 3x, minus x is minus 4x. So now we have 6 minus 4x over 3 times 2 minus x to the 2/3. Okay, I know it's a lot of work because the derivative was the easy part, but then the algebraic simplification was probably a lot more work, because now it's a lot easier to figure out when is this equal to 0 and when is it undefined, because after all, that is the definition of a critical point. A critical point is the value of x that causes the derivative to be 0 or undefined. Let's start by looking at the numerator. For what value of x is 6 minus 4x equal to 0? Well, that would be x equals 3/2. What about the denominator? What value of x causes the bottom to be 0? After all, we're not just looking for the values of x that causes f prime to be undefined, or sorry, f prime to be 0, but also f prime to be undefined. That looks to be x equals 2. Notice that if I put x equals 2 into my denominator, I get 2 minus 2 is 0, and I'll be dividing by 0, which is an undefined value. So x equals 2 is also a critical point. One last thing to check is to make sure x equals 3/2 and x equals 2 are on the domain of the original function f of x. So ask yourself, is it safe to plug in 3/2 and 2 into the original function? It sure is. I can safely plug in 3/2 or 2 because it doesn't cause me to divide by 0. It doesn't cause me to take the cube or the square root of a negative number, and I don't end up taking the log of any negative number. So because of that, both of these values of x are on the domain, and therefore both of them are critical points.